Hello friends, this is Jim with Science Talk. I have two reports to share with you, and they both address the issue of carbon stores. So, two new studies have highlighted yet more unexpected findings in Earth's carbon stores, how the world's waters and soils accumulate and discharge them. This one was a surprise to me. One team of researchers has found that the meltwaters of Greenland are washing measurable quantities of carbon into the atmosphere in the form of methane. Another looked more closely at the way carbon is stored in the world's soils, and they come to the conclusion that even the minerals in the bedrock play a role. With help from rainwater, they can capture and hold potentially vast quantities of carbon in the soils of the planet Earth and possibly release them later. Neither discovery changes the overall huge picture of global warming, but they're both reminders that climate scientists still have to learn a lot. About precisely how the carbon is cycled between living organisms, rocks, atmospheres, water, etc. So, the first report looking at what's going on in Greenland appears in the journal Nature. You had British, Canadian, U.S., German, Czech, and Danish researchers there, and they camped out for 3 months on Greenland. Summer, basically continuous sunlight, to take continuous samples of meltwater from a 600 square kilometer ice sheet. They found, in what they term in their words, a continuous export of methane, 6 tons of it, from the site alone, or roughly the equivalent of what might be released from 100 cows. Don't forget, cows, between burping and farting, add a significant amount of methane. Busy microbes at work below kilometers of ice are producing a greenhouse gas many times more potent as global warming agent than CO2. We know that methane is a more potent greenhouse gas, especially over the short term. Well, you start warming things up, the meltwater starts reaching down, you have a little rinsing effect, if you will, but you have warmer temperatures reaching down there, they're going to start doing their thing. And they're doing their thing is probably releasing methane as a byproduct of their cellular activities. So Gemma Wadham of the University of Bristol's Cabot Institute for the Environment, she's the lead PI, principal investigator, she states a key finding is that much of the methane produced beneath the ice likely escapes the Greenland ice sheet in large, fast-flowing rivers before it can be oxidized to CO2, which is something that typically happens to methane gas. It will get oxidized from CH4 to CO2. So, but it's being released before it can do so. Now, climate scientists have been worrying for decades about the carbon locked in the Arctic permafrost. How many times have I said to you guys that what keeps climate scientists up at night is the methane question in the permafrost? How much is there stored, and at what rate will it be released? Well, here it is. The discovery that even the ice sheets are a source of atmospheric carbon accentuates the scale of the challenge facing those researchers who are trying to figure out the carbon budget, basically. So, basically, this came as a surprise, and now they have to incorporate this finding into the models and adjust accordingly. So now we have these build-up of greenhouse gases, so now the next question would be, how much is naturally absorbed by oceans, forests, and soils? So, not surprisingly, scientists have paid attention to the role of vegetation particularly large forests, in absorbing, removing the carbon from the atmosphere. So in the journal Nature Climate Change is the second study discussing the microbes and the minerals in the soil. I'll discuss that with you. So this new article gives some perhaps new insights. Iron and aluminum bearing minerals in the soils hang on to a lot of carbon, almost like a chelating aspect to it. How much varies according to rainfall and evaporation, but it could be that between 3% and 72% of organic carbon found in soils is retained by reactive minerals. Researchers think in all this could add up to 600 billion metric tons worldwide, most of it in the rainforest. 600 billion metric tons worldwide. That's a shitload. Oliver Chadwick at the University of Santa Barbara, one of the researchers, states when plants photosynthesize, they draw carbon out of the atmosphere, then they die, and organic matter is incorporated in the soil. Bacteria decompose that organic matter, releasing carbon that can either go right back into the atmosphere as CO2, or it can get held on the surface of soil minerals. This is the surprise. Not all of it goes back in the atmosphere. Some of it may be retained in the soil minerals. What the finding means in the long term is not certain. As the researchers say, the capacity of mineral soil to clean the carbon suggests what they call high sensitivity to future changes in climate. That is, with yet more warming, the same mineral soils could now release their imprisoned carbon. Nobody knows at what point this would happen. So, keep in mind now, if we're talking about trees, and they die and become part of the organic matter, that is carbon that's already there. It's not like dig out oil, dig out coal, burn it. So that is not necessarily a human contribution. However, if the warming continues, even that carbon could be released, which will then exacerbate the situation. So even though it may not be humans directly adding that, the additive prospect could make things more dire for us and make controlling or trying to keep the temperature down to 2 or less more difficult. Remember, we can determine, looking at isotopic signature, the source of every CO2 molecule. We can tell if it's from a biological source or from an anthropogenic source. Basically, we can tell, oh, that CO2 molecule came from burning fossil fuel. That CO2 molecule is biological, i.e. from a biological process. But the point is that there may be more CO2 locked away in the grounds, in the soils. Not even this article did not look at the permafrost, and that's another issue which we have discussed. And the warming could now release that CO2, and it may not be a human source per se, but it still will put more CO2 into the atmosphere, which will not help things. That's kind of the basically the take-home message of that. So, Mark Kramer of Washington State University, a co-author of this study, states, "We know less about the soils on Earth than we do about the surface of Mars." That might be a little hyperbolic statement, but I understand what he's saying. Before we can start thinking about storing carbon in the ground, we need to understand how it gets there and how likely it is to stick around. This finding highlights a major breakthrough in our understanding. It almost seems like no matter what we do, we're just screwing ourselves. So, A couple of interesting findings. I said the issue with the Greenland running water and the microbial action of adding methane, that came as a surprise to me. So, till next time, thank you for your time. Thank you for watching. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.